to have it, but I guess now we can have it. Sorry for inconveniences that might have been caused. So today we are going to tackle TinyML frameworks and tools. So mostly we'll be diving deeply into the frameworks that are currently propelling TinyML. Mostly we're going to talk about TensorFlow, TensorFlow Lite, and TensorFlow Lite Micro, and how they fit into the matrix of TinyML. So again, by introduction, my name is Clinton Odor. I'm currently like a machine learning engineer at Mini, and I'm also a contributor at the Impulse Expert Network. So just to start, I'll start my presentation by just going through again what was explored during the first week. So when we're talking about TinyML, we are talking about deploying machine learning models on edge devices, mostly um, mostly. Just a second, let me just mute my. Sorry. Sorry. Okay. So when you're talking about TinyML, we're talking mostly about deploying machine learning model on embedded system. The embedded system are basically like resource constrained, microcontrollers for this case, and there are some compute constraints that they usually suffer from. The first one being low RAM. Most of these devices, you'll find them having a few hundred kilobytes of RAM, or sometimes even less than 100 kilobytes of RAM. They usually suffer from low flash memory, most of them being having a flash memory of less than 1 megabyte. You can compare that maybe to your computer that you might be running a machine learning model that you have built um, on your machine. Sometimes they usually be as big as 500 MB, sometimes even more than 1 GB. And if you compare even the current large language models that are more than 20 GB, 50 GB, and the rest. So you can just imagine trying to squeeze machine learning models, trying to squeeze intelligence to run and to fit into these devices with less than most of the time 1 megabytes of RAM, 1 MB of RAM. These devices also suffer from challenges or constraints such as low clock speed, most of them being 16 megahertz, sometimes even 8, sometimes 32, and for the most use cases, around 48 megahertz. You can compare that maybe to your computer that might be running um, around um, around 2.5 gigahertz of clock speed. So you can just imagine trying to fit these models to run into such devices. Another constraint that these devices usually have is they don't have an operating system. Most of the time, they usually just run on binary. So most of these were covered by Solomon in the first session. So let's look now at the development life cycle, or the development workflow of of TinyML application. Sorry, again, I think there's something messing with me. Sorry for the interruption again. So we are talking about the the development life cycle of a typical TinyML application. For example, you first of all choose a framework of your choice. So for this case, most of the time, TensorFlow is the most commonly used framework for developing models that can further be optimized to run on embedded devices, or even just basic edge accelerators, embedded GPU devices such as the Jetson Nano, which runs GPUs, and even the Coral devices which run edge TPUs. So you'll start by TensorFlow, and for this case, the moment you are choosing TensorFlow, you have a lot of flexibility in terms of what you can really build due to the supported operations. You can work on computer vision models, you can run on speech models, you can run on natural language processing models that sometimes you might not be able to fit in embedded devices, but by choosing TensorFlow, you get a lot of flexibility in what you can build. then when it comes now, when you want to deploy it in an edge device, you can first of all convert it into TensorFlow Lite if you are having like some sort of an edge accelerator or a device that is not limited in terms of resource. These are devices that we have not, the devices that are outside the category that we have just mentioned of microcontrollers. So this might include devices such as Raspberry Pis, which typically usually have like more RAM, about 2 GB, 4 GB of RAM with the latest like Raspberry Pi, or even like devices now such as the NVIDIA Jetson and even like the Google Coral. So this class of devices, you can just optimize your model from TensorFlow Lite from TensorFlow to TensorFlow Lite and run them without really converting them again into TensorFlow Lite Micro. So TensorFlow Lite Micro is surely like the framework that's currently like the most used when it comes to you when you want to deploy like your models on microcontrollers. These are devices such as that the Arduinos and the rest, and the kind of devices that we are currently talking about in this case. So like what are the key features of TensorFlow Lite Micro, and how maybe is it different from TensorFlow and TensorFlow Lite, the typical TensorFlow Lite? So the first one is that the core runtime can fit into a 16 kilobyte RAM. It can fit the core runtime can fit into a RAM of 16 kilobytes. So imagine like most of these devices, for example, for this case, they are doing a Nano 33 license. I'm not quite sure of the exact memory, but it's usually around like 100 kilobytes of RAM. So imagine like you already have like the runtime, the TensorFlow Lite runtime only consume like 16 kilobytes. So it gives you like a bigger flexibility up to about 84 kilobytes of RAM to do other things such as data preprocessing and other digital signal processing tasks, because the runtime only consumes only 16 kilobytes of RAM. So think of any small device that you might have, device that have basically around 20 even 20 kilobytes of RAM, or even like 50 kilobytes of RAM, which falls into the category of like most microcontrollers. So another interesting thing about like TensorFlow Lite Micro, it usually like uses static memory allocation and not dynamic. And this is really important because like you can really predict like what memory your model is going to consume even before you deploy it, because like the memory is defined at the compilation level when you're compiling like your model to run on the runtime, rather than a dynamic where like the memory allocation is determined during like runtime when the model is performing inference. So this gives you like the deterministic approach of knowing whether even before you have deployed like your model, you can know whether your model is really going to run on your target microcontroller or not. The other thing is that it has like a broad platform support. Basically, it's compatible with a variety of 32-bit microcontrollers, which fit into like the into the classes of like most of the microcontrollers that we currently have. Think about the Arduinos. Yeah, I actually have a slide on that here. Think of the Arduino Nano 33 license. Think about like devices such as the SID JAWs, which are typically the size of a thumb, devices such as the Arduino Potenta, and even devices such as this one here, which is almost the size of a coin. So another advantage that TensorFlow Lite Micro has, it's the interoperability with C++. This gives you again a lot of flexibility, especially when you're coming from an embedded system field. It gives you capability of integrating the models that you've built easily with the framework that you are most familiar with. Let's say like if you're an embedded system engineer, most of the time you're going to deal with C and C++. So the runtime usually runs in C++, which gives you again the flexibility to easily integrate it into your existing projects just as a library and nothing complicated. So again, the interpreter itself, it has been designed fully for runtime, fully for runtime, fully for inference, and not for training. So meaning that there are some operations that have been removed to make it like just run on to be used only for inference and not for training, thereby also reducing like the size of the runtime itself. That's why it can fit into like a device with a 16 kilobyte of memory, compared maybe to a normal TensorFlow, which will need, I guess, like GBs of memory or so. So the role of the interpreter is really to control like most of these things that we have currently discussed about, things to do with memory, things to do with operation kernels. So think for operation kernels as the functionalities or the functions that you can perform using like TensorFlow Micro. So be it like matrix multiplication for the convolution neural network, if you are performing like computer vision tasks, or be it like just normal functions for linear regression and the rest. And if I'm not quite sure, the last time I checked, I think TensorFlow Micro had had support for LSTMs, but you need to confirm this. If I think I saw something of the sort. So it also has like a support of very many kernels that can easily fit into most of the type of models that people build. Think of like computer vision applications, speech recognition, which basically speech and sound classification, which usually uses like a convolutional neural network, the same architecture as computer vision models. So it also handles things such as memory efficiency, the static memory allocation, and the rest. So another big advantage of, or another big benefit of the TensorFlow Lite Micro, it gives you like the advantage of having access to already pre-built models that you can easily fine tune to your task, your specific task, your downstream tasks. So when you want to maybe develop like an image classification model, maybe to detect like to differentiate between an elephant and no elephant, it's not a must you start from scratch. Maybe sometimes you don't have like enough images of that particular class that you want to classify. You can use like already pre-built models, like let's say like a person classifier model, and perform like some transfer learning, and with your little images, your little like training set, you can spin up like something very fast without like really going deeply into the hassle of building your new model from scratch. So I think we touch on this, like it's operational without an underlying operating system. So most of these devices, most of TinyML applications usually don't need like an operating system. Most of the time usually just run on binary. If you can just compile your model and your entire application into binary, you can easily run it without using like an operating system. Unlike most of the development platforms, think of even things like Raspberry Pi, which you'll need like something like Raspbian, and maybe NVIDIA Jetson, where you'll need like Jetpack, or even our computers where we have like Windows, Ubuntu already installed in them. So the other big key big feature of the micro, it's like a very big community support. So TensorFlow is framework that's currently being used by very many developers. So it also like gives you the benefit of doubt, or rather like it gives you it encourages you to continue learning it and continue building application with it, because like whenever you're stuck, you can always get like somebody in the community who has maybe faced this type of challenge that you have faced, who can help you firsthand. So the next thing that I wanted to talk about is about tools and platforms. But before we go to tools and platform, I think we can first of all answer some questions before we can move to this to the next step, which I'll be showcasing like some platform that you can use. Is there any question from the chat, please? Let me check.
Hi, Clinton.
Hi, Abu.
Hi. So I have one question. In the
Okay.
slide where you said something about real-time processing,
Uh-huh.
uh, by real-time processing, do you mean online processing with machine learning as a machine learning technique on an edge computing device, or?
Oh, if I get you correctly, yes, I mean real time processing. I mean like you perform inference when just where the data is being collected. You're not like sending it somewhere else to perform like the inference, but you're performing like machine learning inference on the device itself. So when the data is being collected, inference is performed. If I got your question correctly.
Yeah, but now during the training phase,
Uh-huh.
you don't actually train on the microcontroller itself. You train it on another platform, then just upload your results from the training set. Then from the results is where your inferences now are generated, if that's what you're trying to say, or?
Yeah, sure. You're very correct. So TinyML is best purposely built for inference and not for training. So you can train in any platform of your choice. You can train on the cloud or using like platforms like Edge Impulse that I'm going just to showcase here in a matter of maybe seconds. So you can do the development. You can do the training somewhere else. Just compile your model to run on an edge device where now the inference or the real-time processing is going to happen. TinyML has been purposely built for inference and not training.
Okay. Okay, thank you for that.
Okay, welcome. Do we have another question? Okay, if we don't have another question, I guess we can move to the next step. So the next step will be going about to talking about like some of the tools that you can use for development for TinyML. Of course, we have been talking about like TensorFlow Lite Micro a lot here for in this specific session, but you can either choose to use like TensorFlow Lite Micro the way it is. You do the training on your platform or in your computer, then convert it to maybe you have built your models in TensorFlow and convert it to TensorFlow Lite. Into like you convert it maybe to a binary that can run using the TensorFlow Lite micro runtime. You can do that by yourself, but there's some also other platforms that you can also easily use to develop like the models and deploy them on your device. So one of the platforms that you're going to look at is a platform called Edge Impulse. So let me just go back to my screen. So Agimpulse is a TinyML development platform that helps you like build models and deploy them on your edge, on your like embedded on your embedded devices. So it handles like the entire TinyML model development like cycle from data collection to signal processing to the model training to the model compilate to the model like optimization to convert it like to TensorFlow Lite Micro, and further again to convert it into like embedded to a C++ code that can run into your development board of choice. So at the heart of Edge Impulse, usually like a TensorFlow Lite Micro, and I'm just going to show you how you can do that. So I'll stop sharing my screen, share another screen. So if you have a question, just post it on the chat. So I'll just share my other screen. Just a sec. Let me know when you can see my screen, Jacqueline. Can you see my screen?
Yeah.
Awesome. So this is a typical like a development life cycle for any machine learning model and TinyML. So of course it usually starts from like data collection, you build your model, you optimize it, then deploy it in your end device for inference. So this is one of the tools that if you want to develop like any TinyML model very quick, be it like a computer vision task, be it like audio task, be it like a normal regression task, or just normal sensor. Maybe you're dealing with a temperature sensor, humidity sensor, or just basically like a vibration sensor, and you want to maybe detect like some set of some type of vibration from that of a particular movement or a particular machine, let's say for industrial machines such as motors and generators. This is one of the platforms that you can use. So I'll just go through the most important part. So most of it I've already configured it. So of course you'll start with, and most of this is going to be covered in the next sessions. I believe in the next sessions you are going to have like, we are going to have sessions typically like specifically designed for particular use cases. So we are going to have like a session specifically designed for computer vision, a session specifically designed for audio classification, and a session specifically designed for motion classification that we are going to dive in much deeper into. But for this case, I just wanted to show you like one of the tools which is HBS for this case and how you can use it. So of course, you usually start with data acquisition, and there are very many ways you can bring your data to the platform. You can use like data from maybe somewhere else that you have stored, maybe in your computer or in an S3 cloud bucket somewhere. You can also like import data from, you can also like connect a device that you might have, be it like at any development board of your choice, be it, let me share this. These are some of the devices that you can currently connect. You can see like there are very many. Arduino Nano 33B license, which is the most commonly used, I guess, Nuclear Vision, or even any S2, ST32 boards. But there are some specific ones that you can use. Not all are currently supported off the shelf. But in a nutshell, like you can connect like any device of your choice, collect data with, and upload it into this platform. Then once you have done that, you're going to have something like this. You're going to have like the data sets here. And of course, you can choose to split them into like a train test split of your choice. For example, for this case, I did like a 80-20 split. Then, of course, there are some steps that you need to go into, like choosing the type of data that you're trying to deal with, choosing like a pre-processing block or a DSP block, then choosing like your machine learning task that you want to perform. For this case, it's a classification, and the output that you desire. So there's a lot of things that you can configure here. For example, this is an MFV because like it's an audio classification problem. This is the part that I wanted to show. I just want to show like how this platform utilized TensorFlow Lite Micro. So after you have performed like all your digital signal processing task, the next step, of course, usually like if you really need to add like a machine learning layer, of course, you will add like your model there. You have like the capability of choosing the architecture of your choice based on your task. Then you will choose like some, you'll set like some hyperparameters like maybe learning rate, and you can also choose whether you want to perform like some augmentation or not, and the number of cycles or epochs you want to train your model on. Once you have set all that, once you start, once you click training, there's something that I want you to observe here. You'll realize that your model is just trained using like in just the normal way models are usually trained. But at this last step, there will be some profiling that it's going to be done to convert like the model from TensorFlow to TensorFlow Lite Micro. So just now. So it's currently training using like just the normal TensorFlow. Then after it has finished, now it's 7/10, 8/10, let's see. After 10/10, you realize that the model is going to be converted to TensorFlow Lite Micro, and even further quantized into like 8-bit precision for it to reduce like the size, and also like to reduce like the compute requirements or compute resources that are going to be required to run the model at inference. So just to say, so you can see here what happened. The first thing that happened, like the model was converted to TensorFlow Lite float 32 precision. Then it was further converted to an int 8, and some profiling was done using like a custom tool called like for example, Impulse has like a custom tool called like the EOIN tuner that they usually use again to further optimize the model to reduce like its memory and flash compute resources for inference. So this is just a typical like example of how like these platforms like utilize like the power of TensorFlow Lite Micro itself, and just the power of TensorFlow to like train and optimize like models to run on embedded devices. And for example, for this case, you're not limited. Actually, you can switch to expert mode, where maybe if you don't want to use those UI stuffs and you have like some experience with TensorFlow or Keras, you can make the changes here. You can define like your own model and define your own hyperparameters, even the ones that have not been added here. So that's just like an overview of how like this such platforms such as Impulse like use TensorFlow Lite Micro. So much of this is going to be covered in the next session. I don't want to get deeply into it because the people who will be handling like specific use cases are going to handle it. But after that, let's go here. In terms of deployment, you can deploy it in any device of your choice. For example, you can see here the EON compiler that I was talking about. For example, you can turn it on or off if you want, and the model can be quantized, it can be optimized to be quantized in int 8, or you can leave it like unoptimized, but this will consume like a lot of compute resources. You can also change the target of the device that you want to run your model on. There's a whole set of devices here. I believe you can see my screen. See, we have like Nordic devices, we have like Seed Studio devices, we have TI devices, Seed Studio, we have terminal devices, and so on. So yeah, I think that's it from me. Jacqueline, maybe we can take some questions if they're there. Hello. Hey, Jacqueline.
Oh, hi. Can you hear me?
Yeah, I can hear you now.
Okay. Thank you so much, Clinton. So in case anyone has a question, please feel free to unmute, or you can also use the chat section. Yeah, sure, Sharon. We have a recording, and I will share immediately after the session is done.
Hello, I have a question.
Okay.
Yeah, I was asking, when doing the quantization, don't you lose accuracy of the model?
Of course, you lose some accuracy, but from previous from like previous experiments, it's really not like a very huge accuracy, like maybe more than 10% or so. So it's usually like something manageable that you can deal with. But again, like TinyML is also it's all about like trade-offs. There are a lot of things that you want to trade off, like you look at inference speed, because like when again you have like a larger model on before quantization, it might take long to run. Like it's just a matter of what do you care about. Are you willing to lose like some little accuracy for performance, like a little bit are you willing like to lose like a little bit of memory for performance in terms of latency? Or are you just okay again to run just that big model? Don't you care like about latency? So it's just a matter of trade-offs about optimizing like the size of the model, the amount of RAM it's going to consume, and then like the time it's going to use to run. So you just choose like what works for you or what best fits your specific application.
Okay, thank you.
Awesome. Any other question? Yeah, so today we are just introducing you to TensorFlow Lite Micro and some of the tools such as this. But in the next sessions, we are going to run into like some specific like types of application that you can build using like TinyML, computer vision, audio classification, motion classification, and the rest. Today was just like a little bit of a primer of the current landscape of some of the tools and framework that are currently used. So again, like I'm going to share like some resources which will be sent together with the recording of today's session. Some more resources that you can have a look at when you maybe want to dive deeply into how TensorFlow Lite Micro works, and also some of the platforms that can be used, such as like documentations of GenPulse and other platforms also, because GenPulse is not like the only platform that you can use for TinyML. There are other platforms like such as Newton, Labs, and the rest. So we are going to share those as well. Okay, back to you, Jacqueline, if there is no any other question.
Okay, thank you so much, Clinton, for the session. And for those who've joined, thank you so much for sticking around till the end of the session. So tomorrow we have our first, let me call it demo, hands-on, but too bad it will be hands-on for the presenter, but it's going to be our first demo, so we can try to make sense of all the concepts that you've been learning from last week to this week. And for the next 2 weeks, or yeah, I think for the next, is it 2 weeks? No, for the next 2 weeks, 3 weeks will be demos. So it will be demos for the different applications. So make sure to tune in, and I will be sharing the recording immediately after the session, as well as the other resources you can use to understand TensorFlow Lite further. So in case anybody doesn't have any other question, I guess we can end the session there, and let's meet tomorrow, same time. I will share the link. Thank you so much, and have a good night, everyone.
Thank you.
Yeah.
Bye-bye.
Bye.